is the new opening for all Oxford MAT videos from now on, and this will tackle Oxford MAT question 1D 2012. The question asks to find this area. See this area under the line but over the square. So now let's compute this area for by this one less than or equal to C less than or equal to 0. Okay, so let's draw this triangle. This is equal to 1 minus C because we see this is C, this is also 1 minus C. So the area of this triangle is 1 minus C squared over 2. Now, how do we tell whether this is the actual curve? Now, this is going to be a very interesting question. Yep, it's going to be an interesting question. It's going to be 1 minus 2c plus c squared over 2. Interesting equation. And don't forget that the c will be negative here. So this should become 1 plus 2c plus c squared over 2. Interesting. How plus c plus c squared over 2? Where is its minima? We take the derivative. The derivative, we bing the constant turn into the abyss. The linear terms disintegrate into constants, and the quadratics go into linear terms. So c plus 1 equals to 0. This is where we find minima. So therefore, c must be equal to minus 1. So we can now draw this area. And when it's 0, obviously this is going to be 0.5, since this is minus 1. And how about the area when c is greater than 0? Well, this is easy. We can picture this. Let me draw it to the graph. If c is greater than 0, then we need to find this 1 minus this area, which I hope you can all figure it out. The shape on the graph looks like this. Do you know that this curve is a variant of the sigmoid curve, or yes, it's called a sigmoid / logistic curve, and it could be something like a tangent hyperbolic function or something like this, but unlike this crude approximation of a sigmoid, the true sigmoid curve never reaches either 1 or 0. So there, I hope you learn about this amazing sigmoid curve or tangent hyperbolic curve. And the tangent hyperbolic curve has the same properties as the sigmoid curve. And I think it's also practically the same thing because it has the same properties as the sigmoid curve. There, I hope you like this little digression, and goodbye.